Hey there, welcome back. We are to section 2.2 in calculus, and we are going to be talking about the limit of a function. This is going to become a very important part of calculus for right now, and we're going to start here. Here we have a function, x squared minus x plus 2, and we want to know, find a value when x is close to 2. And the way we express that is we write the limit, LIM, as x approaches 2 of f of x. And what we're going to do in this case is we're going to evaluate this function right there. So let's do f of 2. So that goes to 0 there, and that just becomes 4. And graphically, let's talk about that for a second. We have the function here. And this is a parabola, which we know what a parabola is. We have a vertex down here. But as the function is approaching, as x is approaching 2, what y value are we getting close to? So the result of a limit is always going to be a range or a y value that we're looking at. So as I'm approaching it this way, the function is approaching 4. And as I'm approaching it from this way, it's also approaching it at 4. And so that is our limit. Now notice that we are approaching it from both directions. That's going to be important here in just a few minutes, because if we approach it in both directions and we get different y results, then that limit is not going to exist. So let's write this out. Definition. The limit as x approaches a of f of x is going to be L, and L is the limit. So the limit of f of x as x approaches a equals L is basically how you would write this out in English. F of x gets closer and closer to L as x gets closer and closer from both sides of a. Now, section 2.3, we're going to do a much more precise analytical way of a limit, but for right now, we're just going to sort of talk about as we get closer. So view a limit like this. Let's say that you turn and face a wall and you walk halfway to that wall. And then from there, you walk halfway again. And then from there, you walk halfway again. The limit is the wall. You may never get to the wall, that's okay, but the limit still exists. All right, let us continue with this. And we're going to use a graph to come up with the limit. So we're going to find f of 1 and the limit as x approaches 1. So here's 1. And we are going to approach from this side and from that side. And you can see the limit is actually f of 1 in this case is 2. And also the limit as x approaches 1 of f of x is also 2. So notice I approach from the left and the right, and the y value in both cases is 2. Now that's going to change here with other values. So here we're going to have f of 2. So here's x equals 2. Notice y is not there. Y is up here. So f of 2 in this case is 5. But I'm going to notice with the limits, as I'm approaching from the left and from the right, the limit is going to be 3. Three in this case. Notice they're different. F of 2 is 5. We're way up here where we have the solid dot, but the limit is to 3. All right, so let's do one more. F of 3 in this case does not exist. So here's 3. There's an open circle and there's no solid dot. So f of 3 in this case does not exist. However, the limit we can see is approaching 4. So the limit exists, but f of 3 does not exist. That may seem a little weird, and it is, and that's okay. All right, let's move on to example 3 here. So we're going to find the limit as x approaches 1 of x minus 1 over x squared minus 1. And I want to point out that when we put 1 in here, like we tried to do up here, where we just replaced x with the limit value, when we try to do that here, we have a problem. 1 squared is 1, 1 minus 1 is 0. We're dividing by 0 there. That's an issue. So we can't directly find the limit. So let me try to focus this a little bit better here. There we go. So what we're going to end up with, and notice if I plug in x equals 1 here, I get 0 over 0. That's what's called an indeterminate form. We'll talk a lot more about that later in the semester. So I'm going to notice that in the numerator, it's x minus 1. The denominator I can factor. And I'm going to notice the x minus 1s reduce out. This is a nice trick if you can get it to work. Now I can directly plug in that 1 there. 1 plus 1 is 2. So this limit goes to 1/2. Now notice the original was 0 over 0. When I directly plug in x equals 1. Again, that's called an indeterminate form. That means indeterminate for us means we don't know. Could be. There could be a limit. Maybe there is, maybe there isn't. We don't know. In this case, there is. I jumped the gun a little. I did example 3 before example 2, and that's okay. All right, I want to show you guys a little trick with your calculator if you are using a TI-83 or 84. What you can do is you can hit y equals, and you'll notice I've plugged in the square root of x minus 1. Now, when I use x, I use this button here for x. And in the denominator, I have the x minus 1. Notice that's stored as y sub 1. So if I want to evaluate an x value into this function, I'm going to show you a little trick here. So I'm going to quit out of that, second quit. And I'm going to go to variables, vars. I want y variables. And I want function, and there's my y1. So I'm going to hit enter. And I want to evaluate this function. By the way, before we get going on this, I want to point out when I plug in 1 once again, square root of 1 is 1, 1 minus 1 is 0, 1 minus 1 is 0. So this is another 0 over 0 case. So could be a limit. Maybe there's a limit. We don't know. So let's figure that out. But let's approach 1 from the left side, meaning numbers that are smaller than 1. And then from the right side, numbers that are bigger than 1. And let's see what we get. So once again, let me show you how I got this. Vars, y vars, function, y1. And now I'm going to go parenthesis 0.9. And what that's going to do is evaluate this function when x equals 0.9 there and 0.9 there. And there we get it. So we have that. Let's do it again. But now we're going to use 0.99. Now, those of you watching this video, you should be doing this with your calculator. You shouldn't just be watching me do it. Make sure that you practice this. Parenthesis 0.99. Okay. Let's try it again. Vars, y vars, function, y1, 0.999. We'll go to 4 decimal points just because this one's going to be even closer. Vars, y vars function. Again, you should be doing this in your calculator, not just watching me do it. Now 4 nines this time. 1, 2, 3, 4. And that is darn close to 0.5. Let's do it again from the other direction. Vars, y vars function. There we go. 1.001. 0001. So 3 zeros and then a 1. Oops, I missed the 1. Let's do it again. Vars, y vars, y1. Let's see. 1.000. 3 zeros and then a 1. There we are. 0.4999875. Holy cow, that's really close to 0.5. Let's do another one. Vars, y vars function 1.001. So now we're getting further and further away from 1. And you'll notice we're getting further and further away from 0.5. But you can see what we're approaching in this case from both directions is 0.5. So this limit is equal to 1/2 or 0.5. And we'll prove that in just a few minutes, a little bit more definitively instead of using a calculator. All right, definition of one-sided limits. So the right-hand limit is going to look like this. It's the limit as x approaches, now be careful, a with a little plus of f of x. That means that we're approaching it from the right-hand side. So with this graph, that would be this one here from the right-hand side, the green, the right-hand side, for the red, the right-hand side. That's an L limit. So the limit of f of x as x approaches a from the right equals L. Left-hand limit, you can guess. X approaches a from the left-hand side. That's going to be a little negative up there. It's an exponent, sort of. All right. So the limit as x approaches a of f of x equals L only if the limit from the left-hand side equals the limit from the right-hand side. Both end up at the same spot, meaning the same y value. If these two aren't equal, then this limit overall does not exist. And you can see up here, we're approaching 0.5, we're approaching 0.5 from both directions. So we're far away from 1, which is what our limit is, which is what we're approaching. And as we approach closer and closer and closer to 1, we're getting closer and closer and closer to 0.5. All right. Once again, using a graph, you can see here, like when x, what's the limit as x approaches 3 in this case? From the left side and the right side, it's the same value. That's the reason that we have a limit. However, there is no f of 3 in this case. So with the green, the left side, the right side, both of them go to 3. Same with the red. We're both approaching 2. All right, let's move on to page 2. All right. Okay, find the following limits if they exist. So here, maybe that's a little bit hard to see. That's the limit as x approaches 2 from the left-hand side. That's a little negative up there. And emphasize it a little bit. Negative of g of x, which is what we have here. So as we're approaching from the left-hand side, the limit is 4. Now from the right-hand side, there's a little plus there. From the right-hand side, now this might be a little bit hard to see. Let me kind of redraw this a little bit. So this is the function down here with a nice solid circle dot there to make it clear. So from this direction, the limit is 1. But because these limits are different from the left side and the right side, this limit does not exist. But I would like to point out that g of 2 does exist right here at 1. But the overall limit does not exist. Let's do another example over here. Here we have a function, and we can see we're approaching 2 once again. From the left side, we're all the way up here at 3. From the right side, you can see we are approaching 2, and we are down here at 1. Which means this limit does not exist. So let's now do 5. The limit from the left-hand side, that's a negative there, we're approaching this way, we're approaching 2. From the right-hand side, we are also approaching 2. Now, because these are the same, the overall limit is 2. Now, you'll notice g of 5 is not 2. G of 5 is 1. That's okay. Our main emphasis, our main focus is from the left side and the right side. Are they approaching the same spot? Yes, they are. So the limit does exist. Here they are not. They're approaching 2 different places. So the limit does not exist. So example 6 is a little funky. You can see we have this cosine, and you can kind of see a cosine wave here. But as we're approaching 0, it's getting messed up. And you can see we are at 1 and -1 all over the place here. So in this case, the limit does not exist. It would need to go to one specific point, not 1 or -1. So when it's oscillating like that, it's bouncing around like that. Nope. The limit does not exist. All right, let's move on to infinite limits. Here we have the limit as x approaches a of f of x goes to infinity. And you can see both are going to infinity here, positive infinity, and it's possible that the limit as x approaches a, f of x is negative infinity. As we're going here, we're going down to negative infinity. Now it's possible we're getting a negative and positive infinity in 2 different directions. So maybe this one goes to infinity and this side goes to negative infinity. That's okay. But what we're going to end up with are vertical asymptotes. I mean, I'll mention that a little bit more here in just a second. So let's go here. So what is the limit as x approaches 1? Here's 1. And we'll notice what's happening here. This is going off to positive infinity. Which, by the way, if it goes off to infinity, this means that the limit does not exist. So overall, These limits do not exist. Now, your teacher is going to want to see you put the infinity. Then you can draw the conclusion, hey, that means that the limit doesn't exist. Don't just put the limit doesn't exist without demonstrating that it goes off to infinity or something. Teachers tend to not like that. This limit at -1, which is over here, you can see we're going off to negative infinity, which once again means that the limit does not exist. Right? Infinity implies that there is no limit, right? All right, so here, this is a little hard to see. This is as x approaches a from the negative direction. So here's a from the negative direction. You'll notice we're going off to infinity. As we approach a from the positive direction, now these are different functions, obviously. You'll notice that we're going off to, again, this is x is going to a from the positive side. You can see we're going off to infinity. And here we have negative infinity. And once again, negative infinity from the negative side, left side, and from the right side. And by the way, the red line that you see here, maybe it's coming off as purple. So the line is called a vertical asymptote. Of f. All right, let's do some more limits here on page 3. All right, let's refocus that. So what I'm going to do is I have already put into my calculator this function 2x over x minus 3. That's for these next two here. And that's my y2. So you may want to pause this, take a minute and put that into, you can clear this one and put it into y1 or put it into y2. And then the second function I have in y3. Second quit. But what I'm going to do is I'm going to evaluate this function closer and closer and closer to 3 from the positive side. So I'm going to go vars, y vars, or function y1, and let's get something. Now this means that it's slightly larger than 3. So let's do 3 point, oops, vars, y vars, function y1 parenthesis. So I'm going to do 3.0001 and see what we get. Okay. Let's do it again even closer. See what we get. So vars, y vars, function 3.00000001. Okay. So it looks like we are approaching a specific boundary here. And I realized I'm doing y1 and this is my y2. So let's start that again. Vars, y vars, function y2. And now let's do 3.0001. Ooh, that's a big number. So now we're doing this function. Sorry, I messed up before. Let's do it again. Vars, y vars, function y2. 3.000001. Let's see what we get. Ooh. So this is clearly going off to positive infinity. Now let's go from the other direction. Vars, y vars, function y2, not y1, like I did before. Parenthesis. Let's do this at 2.9999999. So we're approaching from the left side. That's the left side there. Ooh, that's a large negative number. We can see that. This is clearly going off to negative infinity. Now this one is my y3, and we're going to approach 2 from the right-hand side. So that's 2.001 or something like that. So let's do that. Vars, y vars. y3 in this case for me. Make sure you keep track of that. And let's go 2.00001. Ooh, that's a large negative number. So now we're going off to negative infinity. from the right-hand side. So we're just going down like that. Let's do this bars, y bars, function y3 for me. And now we're doing slightly less than 2. So that's going to be 1.99999. And that goes off to positive infinity. All right. Well, I hope that was helpful.